How's it going, everyone? Welcome to another video. In this video we're going to talk about how we're going to create now a Redux from scratch, as well as understanding what is the goal and the influence thanks to this particularly blog article made by the Redux one of the Redux maintainers, okay, and get a more hands-on approach when it comes not only to write a Redux from scratch, but also how can we enhance a Redux, look at the API first, understanding what is the goal and the influence, and then the design principle and intent. So then we can make a quick recap of what we have learned and done over the couple videos when we are writing our first Redux from the scratch, and then how now we slowly but progressively look at how all of these design principles, intent, goals, and influence actually make sense, so we can describe that, and also when it needs to provide that to companies, we can do that in the most fast way possible. So this Redux is not exclusively to React, right? This Redux is just a way of how you can make your state mutations predictable, how you can make your state management, as long as that application use JavaScript, right? Whatever JavaScript environment you're working on, the client and on the server. So this Redux, the Redux goal is to make all of these state mutations predictable by actually getting the influence from Redux or from Flux architecture, and say, hey, we want to separate is the state management, the state update, or this state mutation of our in our applications, separate from the rest of the applications. And to do that, and to make this mutations predictable, we need to set up a set of constraints. So that is why we need to use immutability and serializability. And when it comes to immutability, the TLDR is that because we have two type of in JavaScript, we have two type of immutability: assignment immutability and value immutability. Assignment immutability is something that there is actually few value there, especially for developers, because even though that there's some cases, and in my experience over the last 7 years building this kind of applications, errors are not relevant there, because on the immutability or the value immutability, where now value pass, so value is portable, so value pass, so value can start in your application, so you can fetch that value, that data from the server, and then you're going to traverse your application and go through a third-party libraries and come back on all of this. So the thing here is, by looking at how you can make your value immutable, in other words, read-only, okay, because this is one case, right, of how you can make your value immutable in this case, or read-only. We can use as the object.assign in the case of JavaScript, object.assign as a way to tell the author, hey, this value that I'm going to pass to the function is a read-only state. And when you're writing a function, always assume is that the argument that you're getting are read-only, which means is that you're going to create a new object out of that. So this is some part of the fundamental practice, especially for that come from functional programming, as a way to now write or try to predict when errors happen, and avoid them by writing patterns where they can never happen. And this is one of the patterns, especially for read only. But what happens when we need mutable data to be immutable, right? And we're gonna say that again. What happens when we need mutable data to be immutable? In other words, what happens when needed change needs to occur with intent? And that's why the immutability is all about a layer of mechanism to know when the value is mutated and prevent mutation or prevent unexpected mutations, right? So there are now libraries out there that provide now an API to work with your common data structure, arrays, objects, and now they're going to expose certain APIs, so now you can mutate the state by this layer in a way that it is expected, okay? Because we don't have that inner mechanism in JavaScript. And the folks of Facebook create now immutable JS, and also there are another libraries out there called like Imer, all right? All right. Yeah, called like Imer, okay? Where the idea of this is, well, both of them actually provide this layer of control to know when needed change need to occur with intent, so we can prevent any unexpected mutations. So that's why we hit the break here as a way to understand this immutability concept, okay, as well as the serializability. That by following is this, the purity and the immutability. A lot of the time, this is one of the designs or in the intent for Redux applications. It's like, hey, we're slowly going to now show the fundamentals and functional programming concepts. So instead of actually forcing the developers to learn all of this, we're gonna slowly but progressively introduce to this kind of concepts. So we look at that, the immutability and serializability. We describe this because this is what improves the developer experience when it comes to debug the applications, right? And make it easy to know when the data flow and the update logic. So Redux wants all the state updates to be synchronous. So that's one of the goals of this. If you want to have asynchronous behavior, keep them separately from the act of updating your state. So because now instead of actually managing multiple stores, Redux says let's going to combine all of that stores, all of that data, state of data into one to make it easy to perceive that state and debug, as well as having the ability to adding all of these reducers to a single root reducers, where in there you're gonna define is your logic to update this state. So this is the TLDR of this Redux influence and goals, and the design and the intent is that they're gonna influence the design from Flux architectures, make the state update maintainability a top priority by also showing is the action history and a semantic meaning, all right? And they enforce that to make that happen. while showing you the functional programming principles, this introduction to programming principles, making the code testable. Making the code testable, as well as organize your code by slice, or organize your state by slice, and of course make the update logic flow explicit inside of your Reduxer, and when you're going to see that on the DevTools. But make the Redux application minimal and extensible. And that's exactly what we are actually going to do in today's video, right? So because of that, we look at what is this Redux API, which is a very minimal API, yet powerful. It not only works for React, it also works for any, as I mentioned before, any JavaScript environment that where you need to manage the state of the applications, whether it's on the server, on the front end, okay? So we're gonna look at how can we start to see and use that. So first things first, we'll look here, and also the difference between the context and Redux is that Redux is an state management, whereas context is a dependency injection mechanism. It's a transport mechanism. So context say, hey, I'm going to now pass this data to distinct components along the tree, and I'm going to manage that when the state updates, and they're going to trigger those state updates from that. There's some caveats, of course, using the context API, especially because when the value change, Redux react automatically, because this is very specific to React and Redux. So React automatically will call all of the children components under the will call all of the child. Redux will call all of the child components starting from the provider when the value change. So this can cause some rippling effects across your applications. Perhaps this is what you want or not. That's why here you can use some catching mechanisms, like use memo, use callback, where use callback is just to catch the functions between re-rendering, and the memo is computations, or if that particular context needs to handle a lot of state updates, you use then is a Reduxer for that. And there are some other techniques as a way to improve the optimization, which is now split, if you're going to use a Reduxer, now split your context between data and the Reduxer, right? Between the state and the Reduxer. So in any case, but yeah, that was a quick recap of that. Then you have the Redux here, and this is where we're starting to look at this minimal API. So we're starting to see how we can now is create our store, what is doing behind the scene this store, okay? What are the things that we can benefit from our store, which is this, okay? And functions like compose, which what it does is to call these functions in particular order, so from right to left, like that. So it's gonna call is make louder here, and then repeat 3 times, and then embolden. So if we take a look now at the DevTools here, or if we take a look now at this example that is showing up, for example, Okay, didn't. Exactly. So for example here, this is now what are the functionality that when you want to use your store actually is doing, right? So this is a small API that is exposing. The dispatch, the get state, replace reducer, subscribe, all right? And then we slowly but progressively see what are the benefit of, for example, using some of the API that this that Redux expose, right? So for example, the actions creator, which is follow the Flux architecture, it follow the Flux action architecture conventions as a way to make all of these actions predictable and remove errors as much as possible. Okay, so we don't have to repeat ourselves that, and how we can now use that with our reducer, which is this logic for checking all of the possible state mutations that we can do to our state, and define the update logic inside of that, and how we need to make this is part of the rules when it comes to manage the state in our application, state maintain in our applications. So we also look at how we can subscribing and binding actions. This subscriber is just passing a function and then subscribe that to this state. So whenever the state change, this function will now get that data from that. We're gonna get that latest state updates, and then you have now the combined reducer. So again, let me actually do this as a way to look at the Redux. That's right. But Redux API, all right, is this, right? This is the store API. That is actually when you create your store. We look at the compose as a way to know to write or run these functions in a convenient way, right? So what it does is to run these functions from the right. So the value will be provided as the argument to the function standing of the left, which means that it's going to call the function, it's going to call the most rightest function. The exception is the rightmost argument, which can accept multiple arguments, as it will provide the signature for the resulting composing function. So this is a way of how you can now is call these functions similar to an assembly line. When you say, hey, this function, the output will be the argument of the so the output of this right function will be now the argument of the function on the left, right? And so on and so on and so forth. So why this is important? Because when you're starting to now look at other part of the API, so for example, like bind actions, right? Where the idea here is, as the name suggests, is that now that you have the action creator or this particular functions that is going to follow the Flux architecture, Flux actions notations, right? As a way to now make our state management predictable. So we know what is the particular format when any time we define an actions, because we don't repeat ourselves. Okay, that's great. Okay, that's awesome. It's powerful. And what it's doing behind the scenes now is to something that we make this. I actually comment that out here. So what we can think that is doing behind the scenes is pretty much this, right? When it comes to bind those creators, it's like, hey, let, in our case, create this dispatch add and dispatch increment. Okay, so all of this dispatch names before our actions is the outcome, is the result from now receiving is those functions that we passing, of course, like this. Well, in this case we pass this increment and add, but you get the idea. The order is irrelevant here. Add an increment, okay, and then you're going to map for each one of those functions, and those functions, what it's gonna do is to say, all right, I want you to now is compose, which means I want you to now compose or call that function. All right, where now first you're gonna run that function, and the output of that will be now attached to the store dispatch, right? So that will be now the input of the store dispatch as a way to now link that action with the store dispatch, or to map that. So this is quite an interesting thing, at least to know, as a way to, once we look at this bind action, what it's doing behind the scenes, and then the combined reducer, which is, as the name suggests, is attach all of these reducers that is going to handle different state updates, all right, into one. So this combined reducer, which is something that we put here, all right, these combined reducers, the beautiful thing of this is that we are going to now is define where this update logic, to which state this update logic belong. That's pretty much what we're doing here. To which state this update logic belong. The same for this, and so on. And then we're gonna pass that reducer to that, followed by the task. So far we have looked at the 70% of the API, and into this video we're gonna look at now the apply middleware and the extensions. Let's get into this. How can we extend enhancer exercise? There you got it.
So we're going to take a quick challenge break, which is I made one that monitors performance. Why don't you create one that simply console logs the state before we call the reducer, and then console logs it again afterwards, so that we can actually...
Okay.
So at that point, we've got combined reducers, we've got bind action creators, we've got compose, we've got create store. We are...
So far we have looked, so far we got is create store, bind actions, bind create actions, bind create actions, bind actions creator, create store, bind action creator. We look at compose, as well as the combined reducer. Okay, so now what left is the apply middleware.
Down to the last and final method that is on Redux, which is apply middleware. Now, good news and bad news. Good news, it's the last one. Bad news is that there's one more thing that we have to learn about.
Let's get into this. So okay. So far we are going to see is the apply middlewares, right? So good news. is the last one. Bad news, we need to learn more things about it. But I don't think that's bad news at all.
As we kind of get comfortable with this. So clear out some of this again for ourselves.
As we kind of get used to this.
So we'll create just a really quick reducer again. Optional. And it's into it. Second. Just immediately return. I'll be able to call later. I have an text here because it's not middleware. The function of good reason. The Redux dev tools are an calling and a copy. An enhancer is basically if we wanted to add additional functionality to a Redux store, this is a place where we can pass in a function which will get an instance of create store, allow us to do whatever we want, and then pass all the arguments into it. Let's look at a quick diagram here. So we've got create store has got the reducer, takes the initial state and the enhancer. What the enhancer will take is first.
So this is as a way to look at the anatomy of this. The by action create, the store. The create store is this one. And then as you can see, so reducer, preload state, or the reducer, or exactly preload state, the initial state, as well as the enhancer, right? So this is now the enhancer. You may optionally specify it to enhance the store with a third-party capability such as middleware, time travel, persistence. The only store enhancer that ships with Redux is apply. The only store enhancer that ships with Redux is apply middleware. Okay. So is this. So let's take a look at the anatomy, right? Anatomy. There you got it. Okay.
It's a curried function. It returns a function. It's going to take the copy of create. Let's look at a quick
it's a
diagram here.
function.
So we've got create store has got the reducer, takes the initial state and the enhancer. What the enhancer will take is first, it's a curried function. It returns. So we've got create store has got the reducer, takes the initial state and the enhancer. What the enhancer will take is first, it's a curried function.
Okay. So enhancer is a query function. Deprecation and alternate legacies create stores for. Tips: don't create more than one store in application. Instead, use combined reducer to create single root reducer. That's right. Redux state is normally plain JavaScript objects. If your state is a plain object, make sure you never mutate it. Immutable updates require making copies of each level. Exactly. For universal apps that run on the server, create a store instance with every request so they are isolated. Interesting. So you're gonna create a store instance with every request so that they are isolated. Dispatch a few data fetching options to store instance and wait for them to complete before rendering the app on the server. When a store is created, Redux dispatch a dummy actions to your Redux to populate the store with initial state. You are not meant to handle the dummy action directly. You just remember that your Reducer should return some kind of initial state is the first argument, and you will set that. To apply multiple store enhancer, you may use compose. But this is something that you mentioned here, that your enhancers middleware is a suggest way to extend Redux. Okay, it's a suggest way of Redux to do this. Interesting. Okay.
It returns a function. It's going to take the copy of create store that we're calling and a copy of all of the arguments we handed to it. You can do whatever stuff that you need to do, and then actually call create store. To be clear, generally speaking, you probably won't write a lot of enhancers, right? Because you need a pretty good reason. The Redux dev tools are an enhancer, right? Because they are basically wrapping your create store with all the stuff that hooks it into the Chrome or Firefox dev tools, right? And so that's a use case for an enhancer. The other thing we kind of mentioned was apply middleware. The function apply middleware creates an enhancer that we'll see in a second. Well, let's actually look at the syntax here, because it's not as scary as it sounds. Deep into the Chrome or Firefox dev tool. The copy of create store that the store has got the reducer, takes what we want, and then pass all the arguments into it. Let's look at a quick diagram here. So we've got create store has got the reducer, takes the initial state and the enhancer. What the enhancer will take is first, it's a curried function. It returns a function. It's going to take the copy of create store that we're calling and a copy of all of the arguments we handed to it.
Okay, it's a curry function. Okay.
How we could specialize it. One of those techniques is called, in terms of our Ajax function, there are two techniques for how we could specialize it. One of those techniques is called partial application. So let's look at partial application. Here's my Ajax function, line 1. Line 3, I am making a partial application of the Ajax function, and that result is getCustomer. And the way that I have made getCustomer out of Ajax is by pre-specifying the customer API URL as its first input. So envision a utility called partial, which I'm not going to show the implementation of because it doesn't really matter how it's implemented, but it's provided to you by all the functional libraries. It takes a function as its first input, and then it takes as its next inputs a set of arguments to pass along to that function at some point. So it's like presetting those arguments. And we get back a new function called getCustomer. I can take line 4, another partial of Ajax, and provide it 2 inputs and get me a getCurrentUser. But line 5 is better than line 4 for the exact same reason as we just talked about. Line 5 makes a more clear delineation of the relationship between getCurrentUser and getCustomer. That is, getCurrentUser is a partial application of getCustomer.
GetCustomer is a partial application
between getCurrentUser and getCustomer. That is, getCurrentUser is a partial application of getCustomer. So that partial utility allows me, each time I call it, to preset one or more inputs and produce a function which is expecting all the rest of the inputs. That's what partial application is. Partially applying some of the inputs now, receiving all of the inputs later.
Partially apply some of the input now to receive. Partially apply.
That's what partial application is. Partially applying some of the inputs now.
Partially apply some of the inputs now,
receiving all of the inputs.
And receiving all the inputs later.
You'll notice that to do a 2-stage specialization like I did, I had to call partial twice. See that? I had to call partial once, and then I called it a second time to make the getCurrentUser. That's one way of doing specialization, is called partial application. Another way, which quite frankly is much more common within functional programming, you will tend to want to do partial application as you get started, and then you'll find out actually everybody does currying. Okay? And you'll see why as you go along, as we go along in the course and as you get more practice with this. But currying is the much more common form of specialization. I used to tell people, and many people have said this before, I used to tell people that currying was a special form of partial application. I now would describe them more like cousins. They both accomplish the same end goal. They both specialize a generalized function, but they go about it in a somewhat significantly different way. So let's look at currying. Back to our Ajax function. What if I wrote the Ajax function like this? Okay? It looks a little bit different because I have this 3 levels here. I have an Ajax level, and then a get data level, and then a get callback level. So I've got 3 levels of function going on. And notice line 7, when I call it, I'm actually calling I'm doing a first set of parentheses line 7 for the customer API. That provides the URL. And I get back another function which is expecting the next input, and then I get back another function which is expecting the next input. You see where I'm going here? So I've got 3 functions nested, and then I've got 3 function calls. That's what I would sort of refer to as a manual currying. Okay? And you'll sometimes see people define, if they just have a 2 or maybe a 3-level currying, you'll see them list out the functions nested like that. On the next slide, we'll see an alternate way of writing out a manual currying. But that allows me then to call those functions and save off the intermediate function. That's how we get the specialization. If I call Ajax with only customer API, I get back a function which could be called getCustomer. The function on line 2 is essentially getCustomer. Use your equational reasoning and you'll see that they're basically the same thing. And then if I call the getCustomer with the data, what I get back is getCurrentUser. So you'll see the same specialization just as we were doing on the previous slide, but now notice that I didn't have to call like a utility every line. All I had to do to get the more specialized function was just pass in the next input. Pass in an input, get a more specialized function. Pass in another input, get an even more specialized function. And you keep doing that, you keep getting a more specialized function every time. This is a technique called currying. Where does that come from, by the way? The Haskell programming language. Everybody knows or probably has heard at some point or another about Haskell. I don't really know anything at all about Haskell. I can literally write 1 line of Haskell. That's all I know about the programming language Haskell. But what I know is that one of the co-inventors of Haskell, his name was Haskell Curry. He invented this technique of currying, or at least co-invented this technique of currying. We call
Harry Curry. Haskell Curry, a mathematician, bro. Haskell Curry. Okay, so this is a technique to actually this is a technique to pass the input to a function and get a specialized one. Pass the input to a function and get an even further specialized one, and so on and so forth. So enhancer is a curry function. So what is a curry function? What is a curry function? Okay. What is a curry function? It's a function that when you pass, it's a function that you call. It's a function that it's a function that when you call with a set of argument, you get a specialized one. You get a specialized function. You call that specialized function again with a set of arguments, and you get even further you get even a further specialized function.
Write like a binary or an n-ary function. There's no such thing. All
Shit.
inputs go into functions in Haskell. So in Haskell, you don't write like a binary or an n-ary function. There's no such thing. All functions are unary in Haskell. Of currying. We call it currying because it is essentially the way that all inputs go into functions in Haskell. So in Haskell, you don't write like a binary or an n-ary function.
Binary or unary function.
There's no such thing. All functions are unary. In Haskell. So if you want to pass in 3 inputs, what do? You have a curried function that takes them one at a time. There's no such thing as pass all 3 all at once, kind of. So currying comes from this idea of, if I could only pass in 1 input at a time, how could I make multiple inputs go into a function? Sometimes my function needs multiple inputs. Now, this is doing it manually, but it would be nice if, for example, we had a utility that could do that for us. And indeed, we do have a utility that can do that for us. By the way, in the commented lines, you'll notice that I'm reusing the arrow function syntax. Line 1 is the traditional way that is written out. And that you'll see URL and then the fat arrow. Let me highlight this for you. You'll see URL here. My highlighter will ever work. There we go. URL, and then the arrow, and then data, and then an arrow, and then CB, and then an arrow, and then whatever the function needs to do its work. Okay? That's that 3-level nesting. It's just written all in one line. And a lot of functional programmers really like the arrow function syntax because this arrow function syntax is almost identical to the mathematical notation and the Haskell notation for a curried function. That's why they love writing it in that style. I am decidedly not a fan of arrow function syntax, which is why you haven't seen any arrow functions on any of my slides. I'm not a fan of that syntax, but if you absolutely must do this chained arrow currying thing, please do line 2. Do a favor to the reader and at least wrap parentheses around each function boundary. Just slightly more not so crazy on the readability, okay? If I can't convince you not to do nested arrow functions, please at least wrap your arrow functions in parentheses, your nested arrow functions in parentheses. Okay, arrow functions aside, in JavaScript, we can define a utility, and indeed, all functional libraries will provide you a utility. It's often called curry. Sometimes they'll have a variation of it called curry n, meaning like how many I want to curry. It looks like this. You call curry, you tell it how many inputs you're expecting to receive, and then you provided a function. And notice that this function here doesn't have to be manual. Any inputs you're expecting to receive, and then you provided a function. And notice that this function here doesn't have to be manually curried. It's a regular old normal function that's expecting some n number of inputs. This curry utility automatically adapts it into being that unrolled thing that's going to accept one input at a time.
Okay.
In other words, it creates a wrapper adapted function whose job is to keep returning a new function that expects another input until you've provided the specified number of inputs, and then it calls the underlying function with all those collected inputs. And that gives us the ability, line 7, to call AJAX with the URL and get back a getCustomer function, and then call getCustomer with the data object and get back a getCurrentUser function. 7 to call AJAX with the So you'll notice that we have the same outcome with curry as we had with the partial application. We just got there in a decidedly different way. Same outcome, which is that I have a general function AJAX, an intermediately more specific function called getCustomer, and an even more specific getCurrentUser. But with partial application, if you were to look a couple of slides back, to get each level of the specialization, I had to call the utility again. With currying, I call it once at the beginning to set up my function, and then it automatically specializes itself as I pass inputs.
And then automatically
I think that's one of the
specialize
reasons why
as
currying
passive.
is more attractive, is it ends up being that you write fewer calls to these utilities. You call it once to set up a function, and then you just
Partial
automatically
application.
specialize it.
Partial application.
As a matter of
and
fact,
currying.
virtually all functional programming libraries that you will encounter, all of the methods on those functional libraries are automatically already curried. Because it turns out functional programmers want everything to be curried. And if you remember what I said at the very beginning when we were talking about shapes, one of the reasons why functional programmers like curried functions is because they like unary functions. Single input, another output. And you can see that a curried function is exactly that. It is a chain series
It's
of
a
unary
chain series
functions.
of.
Single input, single output, single input, single
It's a
output.
chain. It's a chain of series of unity functions. Single input, single output, single input, single output. It's pretty much like an assembly line, man. It's like single input, single output, single input, single output, single input, single output. It's pretty much like you are, for example, if you have a motorcycle company, is that you have a single, let's say in this phase you're actually getting is all the materials to actually, so in this first stage you get is the design of the motorcycle, and then in the second phase you have now the material of that. And then the third phase is starting to put is the frame of the motorcycle, and then the next one is the wheel. So with all of these different phases, when you get one single input, one single output, one single input, one single output, one single input, one single output, and so on and so on. Is this change of that? That's one of the reasons why it's because it is simplicity for humans, okay? As a way to work with this currying functions. Okay, so if we need to explain this currying function, is that it's a function that take a single input and take a it's a function that take a single input and single output, single input and single output, single input and single output. This is good when you want to now is pass this output to a more specialized function, and so on and so forth. And a good example of that is okay, in a sushi restaurant, okay, yeah, hot dogs and sushi restaurants. So hot dog, this process is made by one person, and in the sushi sometimes you get multiple ones, right? But in the example of hot dog is that, well, you want a hot dog, all right? So they have to do certain things, certain instruction, functions, to actually give you the hot dog. So here first it has Now all the sauce on hot water, the bread, as well as the whatever thing that you want to put on that. So you have your salads and spices, right? So he take that one from that, so one single input, and now the output of this, which is where I'm going to put now this the hot sauce, is in this bread, all right, hot dog bread. I put it here. So next is, well, I'm going to now is apply some of these vegetable that the client needs to. Hey, what do you want? Onions, all right. And then, as you can see, on each different stage, one single input, one single input, one single output, one single input, one single output, one single input, one single output. At the end of that, you're starting to get your hot dog. That's pretty French toast. That's a very sequential way and beautiful to describe now these current functions. And I think this is something important. Okay.
Single input, single output. So in other words, to summarize this partial application versus currying thing, what we could say is that they are accomplishing the same thing, but doing it in a different way.
Doing it in a different way.
Both of them are specialization techniques.
Mm-hmm. Okay. Mm-hmm. Okay. Holy moly. Here we go. Okay. What's a curry function?
Partial application is going to preset some of the arguments at the beginning and then receive all the rest of them on the next call. And if you want to do multiple steps of that specialization, you got to keep calling the utility. But doing it in a different way.
Mm-hmm.
Both of them are specialization techniques. Partial application is going to preset some of the arguments at the beginning and then receive all the rest of them
on the next call.
And if you want to do multiple steps of that specialization, you got to keep calling.
You have to keep calling.
Currying, on the other hand, doesn't preset any of the arguments, and it receives each argument one at a time.
Again, the whole point of this is that they want to get is this specialized function, right? Specialized techniques, right? Both are specialization techniques. Mm-hmm.
If you ever get asked on a future job interview, what's the difference? What's partial application and currying? The answer is both of them specialize.
Exactly, both of them are specialized, but they do it differently. So partial applications, you pass a preset of, you preset some arguments, and now receive you preset some arguments now, and receive the next and receive the rest on the next call. And then you have to call that function again with this new preset of arguments to get this more specialized function, and so on and so forth. Where now here on currying, you don't need to preset any arguments, because you are going to now is pass one single argument at a time.
They do it different. Partial application takes some input now, all the rest of the input later.
Exactly. Partial application takes some inputs now, all the rest input later.
Currying takes no input now.
Currying takes no input now,
Each input one.
and each input at one time.
By the way, I want to back up real quick one slide. Skipped over one thing I didn't want to skip over. There is this notion of what I would call strict versus loose currying. And I'm calling this out because you're going to encounter this, and you may ask yourself. This idea that I've been showing you with currying has been like we see on line 7, which is that each time I call the function, I provide only one input. Because that's how we did it when we manually curried. That's how it works in Haskell. You provide one input at a time. I would call that the canonical or strict interpretation of currying. But if you had a function, say something that received 5 inputs, and you knew 3 of them right now, and you wanted to wait to define the other 2, you can see that it would be a little bit annoying to have to do 3 separate function calls with 3 separate parentheses. It might be much more convenient, like line 10, to just be able to provide 2 inputs all in one call. You see where I'm coming from? So that technique is what I would refer to as loose currying, meaning at each level of the function call, you can pass in 1 or more arguments. And the function that you get back is waiting for whatever the next argument should be.
I prefer to stick with this discipline.
The reason why it's important to point out loose currying is because, as far as I'm aware, every JavaScript functional programming library that I have seen does loose currying, not strict currying. But if you're really trying to adhere to the true notion of what currying was as it was conceived in Haskell, you'd be doing strict currying. I think the reason why those libraries chose the loose currying form is for convenience only, not because it's the more, canonically correct way of doing it. So just be aware when you see something like line 10 where multiple inputs are being passed, that still might be currying. It might just be loose currying instead.
Why does partial applications still exist in functional programming?
That's a good question. So the question is why, if currying is generally preferred, and you will find that it usually is, why even have a partial application? The best answer I can give you, other than the fact that it's sort of historical and once something is in the canonical body of work, it's never going to get removed. Other than that, I would say there are some cases where it would be more convenient to do partial application than currying. For example, let's say you have a function that starts out expecting 5 inputs, and you want to produce another function that expects 3 inputs. You want to preset only 2 of them. If you were to curry it, 2 things would be true. First of all, you'd have to call it twice, and that's a little annoying. But secondly, the function you'd get back would not be a function that was expecting 3 inputs. It would be a curried function of 3 more chains. And that might not be the shape of function that you want to pass around. So it might be the case that the partial application produces a more preferable shape. That's not going to be common, but that's why it might still exist, is that sometimes that tool might produce a function shape that is more preferable than a curried function.
So even though partial applications still exist, because it can be convenient, it can be compelling when it return a certain shape of data. Without the nested change.
Not going to be common, pass around. So it would not be a function that was expecting 3 inputs. It would be a curried function of 3 more chains. And that might not be the shape of function that you want to pass around. So it might be the case that the partial application produces a more preferable shape.
A certain preferable shape. Okay.
That's not going to be...
Yeah, but I don't want to get into the weeds with this. But I know what is a curry function, okay?
But you can do whatever stuff that you need to do, and then actually call create store.
So this is a curry function that you're gonna take all of these arguments. Again, remember, don't mix curry with partial applications, okay?
To be clear, generally speaking, you probably won't write a lot of enhancers, right? Because you need a pretty good reason. The Redux dev tools are an enhancer, right? Because they are basically wrapping your create store with...
So enhancers.
all the stuff that hooks it into the Chrome or Firefox dev tools, right? And so that's a use case for an enhancer.
Do stuff here, take another shot at calling create stuff with your modified stuff, and then you call. So enhancer is a query function. Okay, so enhancer is a query function which you can now call all of the things needed, and then when you call that create store with a more specialized things, you can pass that. All right. So enhancer is a current function where you can define a set of things you want to do, and then call the create store or this special or this or a function with now specialized arguments or specialized inputs. With a specialized inputs. So what you're doing here is that you're going to do some stuff here as a way to set up things that you need to, and then you're going to now pass those inputs to these another functions that is going to do some specific things. But again, this is some specialization techniques. Both of them, partial application and currying, is that with partial application you preset some of the arguments, pass that to the functions, you preset some of the inputs, and call that, so you can let it on pass pass other inputs on subsequent calls. Where now currying is that you don't pass any input at the beginning, and then you call that function with one input at a time. Okay, so one input, one output, one input, one output. You have now this change of functions that receive one input and one output, one input and one output. What is the subtle difference here? Is that, well, partial application can be quite convenient when it provides certain shape that is relevant, useful, instead of actually having you to call this series of change on curry function.
The other thing we kind of mentioned was apply middleware. The function apply middleware creates an enhancer that we'll see in a second. Well, let's actually look at the syntax here, because it's not as scary as it sounds.
Not at all.
So I'm going to write one, and then you're going to write one, and then we will talk about it together as a team. So we can go ahead and let's say we want to have an enhancer that theoretically monitors, like takes performance metrics of everything happening in Redux. That seems legitimate, right? So we could say we'll call it monitor enhancer, and that's going to get a copy of the create store function that it'll be able to call later, and it's also going to get reducer, initial state, and enhancer. Cool. And what we'll be able to do is we will
exactly. But here you are now is creating this curry function or this partial application here. What initially when you are defining is you're gonna get the create store, you're gonna run that store later on.
Eventually you could go ahead
first
and
you're gonna do
return.
is some initialization, some logic here, some stuff here.
This is a
some set of
enhancer that doesn't do
instructions, commands.
State.
You wanna do this.
Okay. And we'll call it immediately. But if you want to like do stuff like wrap the reducer in another function that prepares it. So hypothetically, if we want to take a performance benchmark before we call the reducer, and then a performance benchmark after we call the reducer, and console log it, we can do that here and then pass that wrapped reducer.
So for example, all right. So example, we want to benchmark now. Yeah, we want to benchmark now. When we want to benchmark, so we want to benchmark how long a dispatch function took. Okay, how long a dispatch function took or takes. All right, we want to benchmark how long a dispatch function takes. ¿Cuánto tiempo dura? ¿O duró? takes to run, right? Takes to run. ¿Cuánto tiempo dura para ejecutarse? Takes to run, right? Exactly. And then now call the function, and I call create function or create store with this specialized inputs. Okay. As a way to enhance the functionality, exactly, as a way to enhance the functionality of our store. Redux DevTool actually use this approach. Let's get into the weeds, bro. All right. So use user test. Let's get into this. Let's get into this. Let's get into this. Let's get into this, fellas. Okay. Store.getState. All right. Good. So now here it's going to we're going to create is this, right?
To the actual create store. So we can go ahead and we'll say something like const start equals performance now. Const end equals performance.now.
Exactly.
And the diff.
And now we want to know is the difference between is star n minus star.
And so it'll be the difference between the end time and the start time. I'll just spell const right. And here we'll actually just say.
Here we want to know is we want to perform is that action, right? New state.
Well, we'll just call the reducer function because it's just a JavaScript function, right?
Reducer.
We'll say state and action. Instead of state, we're going to say start down here.
Okay.
All right. Oh, we gotta wrap this. Hold on. We need to we'll make a reducer. Hold on. So we'll say replace reducer. Well, we'll say monitor reducer.
Monitor reducer.
That is going to take state and action.
State and action. We're going to return is a
pull all this in.
Here.
Pull the real reducer once we've taken our performance
the
metrics
new
with state
state.
And then return the new state.
Exactly.
Let's also console log that diff.
Then I want to know how long it takes. The diff.
Great. All right, so we've got that kind of in place. This enhancer doesn't work here because it doesn't really exist, so we'll replace it real quick.
Exactly, we're gonna pass that. You know, with this specialized function, oh my god, it's a lot of concept. You know, that's one of the reasons why here, something that I love from Redux, part of the design principle is that, and the intent is that, yeah, we're going to make the state mutations maintainable as much as possible as a top priority. The influence of this is the Flux architecture, good. We want to make all of the action history meaningful and semantic and meaningful. All right, but we also want you to introduce to this functional programming concepts slowly but progressively. One of them is curry. And that's exactly what we did here. Oh my god. Oh, no, I love it. What? Yeah, fucking man. You're duplicating that? Exactly. This is the end. You got it? Alright. So here we're gonna create is our so first we're gonna create is now the monitor enhancer, okay, which is monitor. This is the monitor enhancer. Remember that after all, what we want to do is just to check the performance of how long now a reducer take, right? When it comes to update the new states, right? So monitor enhancer, which is you're going to now get this store as a first input, all right, and then this is something known as the loosely this is something known as loosely curring. Why? Because remember, at the end of the day, partial application and curring functions are just specialized techniques, okay, where you're going to go now provide some inputs and get a new output. But this output will be now the input to a new function that's going to produce you now a more specialized output, so on and so on and so forth. So pretty much like on ice cream, right? So just say, hey, I want now an ice cream with 4 flavors, right? So now you're gonna choose which cup you wanna get, okay? And they're going to tell you, and they're gonna say, hey, which one of the flavor you want? Oh, it's this one. Banana splits, mocha, tiramisu, and lemon. You shouldn't make that combination. It will, you can die from that, lemon and tiramisu. But in any case, you want to combine it, right? So one input, one output. You got one. Then you got the tiramisu. One input, one output. You get now a more complex output. What you have now is the Oreo and the tiramisu, and then you put now here is lemon, right? But all of these actions that you're gonna do, which is one after the another, that's why it's curring functions. Is that initially won't take any inputs, and then it will now call those functions with one single input and one single output, one single input, one single output, as a change of functions here. So with partial application, here you're going to preset some of the arguments, and then later on pass the rest of the inputs, right, as you call them. So why we're using now partial application? Because this is quite convenient when you need to return a shape, which is exactly what we're gonna do in this moment. So once we create the store, and this store that we receive as an input, okay, now it will so now once we call this, interesting. So now that we receive this store, the second argument here that we're gonna receive is the input from that store, and that is the reducers argument. Reducer, they can be initial state, okay, and the enhancer. Why it makes it quite complicated to actually look at the shape of this. And now we're not going to use this, but it's important to understand where the thing coming from. Store creator, right? Where here you're going to pass is the reducer and the enhancer, or the preload state and the enhancer, right? So in this particular case, we're going to pass is the reducer, is this one, exactly, the reducer, the initial state, and the enhancer, right? Enhancer. So what does it mean? That when we are calling this function, so the first time we're calling the monitor enhancer, we're gonna need to pass is the create store, and here we can say simply is, hey, I just want to return, right? Return is the create store, right? Or just like this, you can say, hey, you just want to return is the create store, which means I just want to output this, so dispatch and subscribe the dispatch, subscribe, and that kind of thing, right? You got the reducer, the initial state, and the enhancer. So far so good, right? No problem with that. One of the thing here is that if you want to now add some logic here and then run this function with a specialized argument as a way to output, to return this in a specialized with a specialized parameter, okay? So pretty much with the example of the ice cream, okay? So here we're gonna say is let's going to define now something called the monitor reducer, maybe monitor reducer here, okay? Where here this may be a function, that's right. So you're gonna get the state and the state and the action here, okay. And here you want us to now measure that, it's gonna measure this. So we have now the const star, which is using the global API, web API from us, which is performance. So you got the performance the now, all right, followed by the n, right, performance dot now, okay. It's going to output is now a timestamp, like that. Yep. Gonna output the timestamp. I want to know is now the difference, right? So diff between the n and star, and because you're gonna give me a particularly huge integer or a huge floating point, I want you to now is give me rounded, right? And then I'm going to now is, well, actually call that reducer, which is const reducer, and that is yeah, reducer or the new state, because after all the reducer return is a new state. So I'm gonna call this reducer here with the state and the action, and this will give me is now the new state, okay. And then right after that I just want is to return is the new state, right? So this is what I'm going to pass now to the monitor reducer, like this, right? So what I'm doing is now passing a more specialized things here, but this is quite interesting.
We have one. Clear that out. Enhancer is not a function.
I think you need to pass it to monitor reducer.
Well.
Exactly. So what you're doing here is that now you're passing is this more specialized thing that this function needs to. You're passing now a specialized input to this function that you want to do.
Where's that other answer?
And then is when you're going to call that.
This one doesn't exist. That's fine. All right, I need to quickly change something. I'm calling it inside here, but this is enhancer.
Exactly.
And now we'll pass our new monitor.
And now we're passing is, that's right. So now when you are creating that, you have some flaw here. So when you are now create your store, you're gonna pass now is the reducer, which is something that we don't define that. No problem. Let's go to define our reducer here. This update logic. Reducer, the update logic here, reducer, which you have the state, and then it's returning now the state, right? Simple reducer. The other argument that it receives is the initial state. I don't have any initial state here, right? So that's why it's passing this as it is. All right, and then now the enhancer, which is, hey, I'm now going to provide you this enhancer where I pass now this particularly functions, okay, where now query that, where now apply some specialized techniques. We're now going to derive, we're going now to return you a specialized output, given this input. And of course I need to actually assign that. Assign to a store, right? And then he say create store, say reducer, right? And then it tells me it looks like you're passing several store enhancer to create store. This is not supported, instead compose them together into a single function. Oh, of course, let me actually is now look at the diff here. Okay, because we're returning now this monitor reducer. And the thing here is that is a composing together into a single function.
Perfect.
Okay.
So now we have one in place where we can dispatch some actions.
Exactly. Now we can
Doesn't really matter
dispatch an
since
action.
Redux doesn't really do anything.
Store dot dispatch.
And we can see, we'll actually just get rid of the rounding.
Yeah, but
You
this
can see that now.
we can dispatch now an action that is the type yo right, store dispatch is dispatch. Okay, store dot dispatch does dispatch exactly. And now we can actually is dispatch several things. Yo, what up? Take a look at that here. But it's on the index, right? And we can actually see this one. But yeah, I want to show is the entire floating point, not as an integer. I want to show its entire floating point. And now we're able to see this. All right. And there you got it. Okay, but yeah, so we are dispatching is now store here is actually.
Now I'm logging the actual time it takes to run through the reducer.
If we reload this.
every time. So this allows you to create like reusable plugins effectively for Redux that you can pass in there, and now it'll wrap every single call to the reducer in the performance metrics. So now they just pass this in. Same thing with the Redux dev tools, as we'll see before. You can pass in these enhancers. It will wrap and extend it almost like a plugin architecture for Redux as well. The question was, is the role of enhancer kind of a middleware? Yes is the answer. Apply middleware is the function we're going to take a look at in a second. Apply middleware takes a whole bunch of different middlewares and creates one composed enhancer out of all of that middleware. Enhancers themselves can be used for a lot of things. Adding middleware, using for the Redux.
But yeah, because that happens so quickly, it's like do that again. Because that happens so quickly, it's like, yeah. But the whole point of this is that you can now define is this set of enhancer or middlewares, okay?
The performance metrics. So now they just pass this in. Same thing with the Redux dev tools, as we'll see before. You can pass in these, and Redux doesn't really do anything. You can see that now I'm logging the actual time it takes to run through the reducer every time. So this allows you to create like reusable plugins effectively for Redux that you can pass in there, and now it'll wrap every single, doesn't really matter now, it'll wrap every single call to the reducer in the performance metrics. So now they just pass this in. Same thing with the Redux dev tools, as we'll see before. You can pass in these enhancers. It will wrap and extend it almost like a plugin architecture for Redux as well. The question was, is the role of enhancer kind of a middleware? Yes is the answer. Apply middleware is the function we're going to take a look at in a second.
So that's right. So that's why we'll look at this. No, all right. Okay. All right. Okay. Okay, bitch. Okay. And some enhancer
so
exercise.
we're going to take a quick challenge break, which is I made one that monitors the performance. Why don't you create one that simply console logs the state before we call the reducer, and then console logs it again afterwards, so that we can actually see before and after on every single action that flows through, right? State before we call the reducer. I made one that monitors the performance. Why don't you create one that simply console logs the state before we call the reducer,
before we call the reducer,
and then console logs it again afterwards, so that we can actually see before and after on every single action that flows through, right? This is something you might want to like turn on in development. Now you don't have to add console logs all over your reducers. You make one enhancer. Every action that flows through will console log before we hit the reducer and after. So it'll be very similar to what we see in this monitor reducer, with a little bit different of an implementation.
exactly.
So our mission was to create a log enhancer that behaves a lot like the monitor enhancer, but instead of monitoring, logs. Did anyone figure this out? Do you want to walk through it together? It's kind of like a little bit of a swapping exercise here as well, but it's again to kind of just get our hands dirty, get some muscle memory around some of this stuff as well.
Yeah, it's gonna
Did we have a name that we liked? What did we call our log enhancer? I'm not good at naming things. That and cache invalidation. Call it log enhancer? You like log enhancer? Give me a collective nod. All right.
Call log
That's good, because
enhancer.
that's what I had in my notes. So again, it starts as a function that will take create store and returns a function that will take all the rest. Reducer,
initial states, and enhancer, right? So then you're gonna create now the set of
and then we're gonna
steps
cre-
that need
just whatever the
to
kind of new
actually
reduce-
pass that to that function. In other words, here this is a query function, which means that we're going to now is provide a specialized output once we run this input, once we run this function with this particular function. Jesus. We're going to now return a specialized output once we run this function with this specific inputs, right? That's what you have now, partial applications and querying, where the subtle difference is that in partial application you preset arguments initially, and then the rest of them later on. But in current, you don't specialize any arguments initially, and then you're going to pass each one of them one at a time, right? That's why a lot of functional programmers actually love to do that, because you can now get this one single input, one single output, one single input, single output. That output will be the input of the, or that output will be the argument of the next function. Again, single input, single output, single input, single output, single input, single output. Pretty much like an assembly line of motorcycles, or even though, an assembly line of motorcycles or cars. It's like that.
So we're using effectively like closures in JavaScript to make a function that's wrapping whatever reducer function they passed in. So we'll say, in this case, we'll say const log reducer. That seems consistent at least. And that will have the same API as any other reducer. And it'll go ahead and we can say console log. We will console log the state. Let's call it old state. We'll actually call it real reducer now with the state and the action. And then we'll console log new state with the state. And just for fun, I'm going to add the action to each of those as well. So like if we had multiple actions within our application, we could see which action triggered that change. And now all we have to do is return that new state. Let's actually fix that. So we're going to call the reducer.
Exactly, you console log with the old state, right? And then you console log with the new state. This reducer. This reducer is the new
store
state.
the result of that function into new state, and then we'll return it out of our wrapped reducer. And now we just return.
And then you return now the create store with this specialized input to get you a specialized output.
Real create store. We'll finally call it after we intercepted it with our log reducer instead, which wraps our whatever reducer they gave us.
With the log reducer, the initial state and the enhancer. Let's going to do this. It's gonna do this because it's not that hard as it is. So here we're gonna create now a log enhancer, right? Log enhancer, log state enhancer, right? So this enhancers, which is a current function that is going to get is the store function initially, all right, and then is the argument from that store, which is the reducer, the initial state, and then the enhancer, right? Where now we're going to define is our set of our logic that this functions needs to return when you're going to now a specialized output for this enhancer, for this new store that we're going to pass that, which is, hey, let's going to define this setup here by defining is the log enhancer, log reducer in this case, log state reducer, right? Where here you say, okay, now that I'm receiving is the state and the action because this is a reducer. Okay, I just want to do is this. Just want to console log is the old state, is the old. So old state, right? What you're gonna show is the state, right? Yeah, pretty much is that. You can also show is the action. Then perform the operation, which is called the reducer. Say reducer with the state and the action at that moment. Okay, and then you're going to assign that to a new state because this is what reducer actually does, right? console log that. I don't want to repeat myself. Okay, and there you got it, right? All state, and this is now the new state. You're gonna show now the new state as well as the action, and then because I want to, this is a log state reducer, I don't want to mutate anything. I just want it, this is an enhancer. I just want to return now this new state for that. That when I'm going to pass now this specialized function with this specific inputs to the create store. Okay, that is, hey, this is now the reducer. This is the specialized log state reducer, followed by the initial state if you have one, and the enhancer. So now here I'm going to now add that store with the enhancer needed, which is a log state enhancer, right? But it say, hey, this looks like you're passing several stores enhancer to create store. This is not supported. Instead, compose them together into a single function. So what we can do is to say, hey, use the compose from Redux and say, well, I want you to now is compose is the this one, the log state enhancer, followed by the monitor enhancer. Okay, and this will be now the compose, okay, which is compose enhancers, right? So now we can is by using that functionality is gonna do what we need to. So we rerun this, and voila, this is now the change that we apply here. All right, and as you can see is this one, Joe and what up. Exactly, because this is the old state. It's undefined and undefined. There is no state for that, but there is an action here as expected, right? So this is now how we can is create this an enhancer, get a more hands-on approach of this functional concept and a more practical approach of this functional concept like currying, all right, and partial applications, as well as the compose for that. That was a very, 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 very interesting things to do. Wait, what?
The problem is that there's one enhancer argument. So we'll say like, you can see it in there as well. And so now we have a log enhancer and a monitor enhancer. The problem is that there's one enhancer argument. So let's say hypothetically, I have a situation where I want to use two enhancers, but create store only takes one enhancer. And I want to pass create store to both of those enhancers. Does anyone have a way that I could do that?
Compose?
Compose function.
Yes, compose, perfect, right? And so what I could in this case do is I could compose, and I'll do my log enhancer, log enhancer, and my monitor enhancer as well. And now you can see that both are happening. So compose, again, you could write compose yourself. You could use the compose from Lodash or pipe or flow or whatever. It's just there to be helpful to you. So that's enhancers. And as I kind of alluded to before when we were asking and answering questions, was apply middleware creates one enhancer out of a series of a chain of
So apply middleware creates one enhancer out of a series of chains of middleware.
One of the useful ways to think about this is
Okay. So that'll be all for this video. Take care. Bye-bye.